Hi everyone and welcome to today's lesson on cracking. As we start, let's review some prior learning that's required to access this lesson. First of all, I know what a catalyst is, so we should know from our Unit 1 knowledge that a catalyst is a substance that is added to a reaction that allows the reaction rate to increase so we can get our products faster, and a catalyst is not itself used up within the reaction. Secondly, I can describe the process of fractional distillation. So we know from earlier in this topic that crude oil can be separated out into its component parts using fractional distillation. The different groups of molecules are called fractions. They have similar boiling points. And remember that word distillation is to do with a separating process where a mixture is split up due to differences in boiling points. I know the structural differences between alkanes and alkenes. So we know that alkenes have the carbon-to-carbon double bond. And then I can write molecular formula for alkanes and alkenes. So for example, propane would be C3H8 and propene would be C3H6. Okay, so remember molecular formula is just how many of each type of atom are in the molecule. For today's learning, I can describe the process of catalytic cracking to convert less useful fractions into more useful fractions. And I can state that cracking produces a mixture of alkanes and alkenes. Let's think back to our process of fractional distillation. Okay, so what happens is at the start, the crude oil comes in to the fractional distillating column. It gets warmed up in the furnace here, and then it goes into the distillating column. Now, it's hottest at the bottom of the distillating column, and the substances that are the biggest, they don't boil off at all. So they actually come down through here, and that's your bitumen and residue. They're the large molecules, long carbon chains, high boiling points, high viscosity, and low flammability. Our smallest molecules, the ones that are collected near the top, they travel all the way up because they evaporate very easily at low temperatures and we can collect them. Now, these are the ones that are most useful for industrial applications, the ones with the smallest mass, the smallest sized molecules and the shortest carbon chains. Some of these are useful, but actually, in industry, because these ones are so much more useful, then chemists are interested in finding ways of converting these longer, less useful fractions into the smaller, more useful fractions. And that's where cracking comes in. I've added in this week this little pencil mark so that you can remember where to take notes in your jotter. Also reminds me as well. So what is cracking? Fractional distillation of crude oil gives more long-chained hydrocarbons than are needed by industry. Cracking produces smaller, more useful molecules. Okay, smaller, more useful molecules. This is achieved by heating large hydrocarbon molecules in the presence of a catalyst. Okay, remember to pause the video at any time if you need more time to take down notes. So what does this look like? Okay, so let's imagine we're starting off with this long hydrocarbon. Now, I know this is not particularly long, but for our illustration, it's going to be absolutely perfect. So this is hexane, okay? And it's got the formula C6H14. Now, we can crack it, okay? Remember, using a catalyst through an industrial process, and or a lab process, we can do it in the lab as well, to make more useful ones. So up here, I've got an alkene. This is ethene, which has the formula C2H4. And then down here, I've got butane, which has the formula C4H10. And what we'll notice is that if we write this as a molecular formula equation, we've gone C6H14 changes into C2H4 and C4H10. Okay, so if we just look at the equation, we can see that the number of carbons is equal on both sides and the number of hydrogens is equal on both sides. What about the catalyst then? So the catalyst that is often used for this purpose is aluminium oxide. Aluminium oxide has the formula Al2O3 because aluminium has a valency of 3, oxygen has a valency of 2, and we swap the valencies over. There are other possible catalysts for this process. You can actually use a bit of broken ceramic pot as a good catalyst for this process, but aluminium oxide is a good one to know and remember. The catalyst allows cracking to take place at a lower temperature, okay, not requiring as much energy, which makes the process cheaper. That's why it's an advantage to do in industry. What about the products of cracking then? Well, if we look back at our example, we will notice that when we cracked hexane, we got ethene, which is an alkene, and we got butane, which is an alkane. Now, it wouldn't have been possible for us to make two alkanes because there wouldn't have been enough hydrogens to make both products alkanes. So the products of cracking then, there are not enough hydrogen atoms for all of the products to be alkanes. At least one of the molecules will need to form a double bond instead. So we will always get a mixture of alkanes and alkenes. Okay, so let's look at what this might look like if we were given, for example, full structural formula. So I'm going to draw out octane. So octane has 8 carbons in its chain, and because octane is an alkane, it's going to have double the number of hydrogens as carbon plus 2. Okay, so it's going to have, so C8H18. So this is my octane molecule. And let's say I'm going to break it up here. Okay, I'm going to crack it there. Then I'm going to have C3H8 on this side. And I'm going to have C5. Think about how many hydrogens I'm going to have. C5H10. Okay, so this was octane, C8H18, and I cracked it and I got propane and pentene. C5, oops, I've missed out. H1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Sometimes we could also be asked, so for example, we could be given a formula, C12H26 was cracked. One product was C9H20. Name the other product. Okay, so let's do an equation. C12H26 is cracked. One product is C9H20. So the other product is going to be C, well, I've got 12 on the left-hand side, 9 on the right, so I need 3. And then the number of hydrogens, I've got 26 on the left and 20 on the right, so there's 6 left over. Now the question asks for the name, so C3H6, this is going to be the one that's an alkene, so it's going to be propene. Okay, let's recap then on that learning about cracking. So I can describe the process of catalytic cracking to convert less useful fractions into more useful fractions, and I can state that cracking produces a mixture of alkanes and alkenes.